Hi everyone. So in this video, I'll talk about how we can transform the parent function of this cube root of x into some other functions, okay, by using this example. So again, if you like to pause and try this on your own before I try, so that would be great. And maybe you can like use some like graphing tools to explore these kind of functions as well. That's for sure. But let's try this without using any tools, and then we can take a look at the end just to confirm, okay? So whenever we have a function, let me write this in general. So y equals a times, like any function, but for the sake of this, I'm gonna go with cube, x minus h, okay, and plus k. And this is one of the general way of the form that we use for any the cube root function. So this number right here, x minus h, the h will tell us how many units are we gonna like shift it on the horizontal axis. Okay, so in our case it's x minus 3, which means we are gonna translate 3 units to the right. Okay, so if you're not sure why we are moving to the right, then I'll ask you to review the basic of the shifting, and also you can explore those on your any graphing tool to see how each of those parameters will affect our graph. So meaning that I will move this function 3 units to the right. So it is 0, so that will be right there. So for the next point, we have in this case like 8 comma 2, right? So that will be if you add 8 to this number, so you will get 11 basically, because right now it's just 3, so that's 10, so it will be 11 right here. So I will get something right here. And it's not really perfectly, but and then if you move this 11 units to the left, and then you will get 3 already here. So that will be, I guess, -5. Let me double check. So we want to get the negative 2, right? So that will be -8, so that should be -5. So you will get something right there. So again, this is gonna be a graph. So if I try my kind of best attempt, so it will be like this. Okay, something like this. So the graph just shifted 3 units to the right because of the x minus 3, okay? So now I will take the effect of the 2. So you can take these effects in order. We usually would like to do the shifting first. And if I look at this guy, the k will shift our function like vertically by k units if this is a positive number. So you will shift it like that many units up, so which is 2 units up. So if I just take this guy 2 units up, so I will get right here. And the other points will not affect it, so it will be something right there. And then 5 will be -5. So something like this, right? And it will be something. It goes on both directions. So again, I hope that's not too bad graphing. So it is just like this and that, okay? So now we are done with this. Like what we have now, so maybe I should write it. So I'm gonna call this is y prime prime, just transforming after 2 times, is equal to square root of x minus 3 plus 2. And then the previous one was this guy. I'm going to call that's y prime. You can name differently. Is equal to square root of x minus 3. Okay, so that was it. Okay, so now what we want to do is multiply this by -2. So just ask yourself, like, how this is going to be affecting, right? So ask yourself to see if you can figure this out. So like we got this, okay, the original point was right here, 0, 0, but now it's just like 3 comma 2. We just move 3 units right and 2 units up. And then we are gonna multiply this guy by -2. But how this is gonna affect? So let's let's think about a couple points just to see if that will give us a bit understanding, okay? So let's try that in a different color. Okay, so like if I want to do maybe x equals like choose the first point we have like 3 comma 2, right? Let's choose 3 for x. If I choose x is 3, then let's see y value. So this guy will be 0, right? So nothing will really change. This guy will be 0. And negative 2 times is like the cube root of 0 is also 0. So that will be just 2. Okay, so that wasn't too bad. So 3 comma 2 is the point. And if I choose like another point, I like to choose something that will make my life not too complicated. So if I want to choose x is 4, because that will make nicer in the cube root. And then the 4 minus 3 is 1. So cube root of 1 is 1. So negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. So the y will be 0. And that will be 4 comma 0. Okay. So you have 4 comma 0. So it will be like this. Okay. And we had 3 comma 2. So which was this point. Okay. And maybe we can choose something else. Let's try to make inside negative. So like if I want to make this inside negative 1, so the x should be 2, right? So if I choose x is 2, if I choose x is 2, so that will give us the negative 1. So cube root of negative like 1 will be negative 1. So negative 2 times negative 1 is 2. 2 plus 2 is 4. Okay, so you get 2 comma 4. Okay, this is good as well. So we got 2 and 4. But I hope, like, when you have these 3 points, it doesn't really give you any idea how the graph looks like. But your parent function, the shape shouldn't be changing, right? But at least we know that when you have this negative sign in front, you know that the graph will be reflect over that I will say midpoint. So like y equals this line. So this was the last equation that we had, this guy, and then the right in the middle is kind of like here. So if you multiply this by a negative number, the graph will be just reflect over this line y equals 2. Okay, so that is something we need to know. If that's the case, this branch will actually move up, and then this branch will move downward. So which is obvious because of the negative. But where this graph will like touch, that's also important. So maybe we should choose x is 0, right? If I choose x is 0, it's not really nicer graph, so that will be negative like 3. But if I choose negative 1, maybe that will be helpful. So if I choose x equals negative 1, again, since we have the choice, so we don't really need to worry about that much, but it's good to know when you have no choices, okay? And if I have x is negative 1, so that will be negative 4. So actually negative 1 doesn't work. I thought square root, but I like to choose like maybe then negative 6, right? Let's choose this negative 6. If I choose negative 6, right? And that will give us the negative 9. No, that doesn't work. Okay, actually, I'm not sure why I'm thinking about the square root. But let's choose x like something that will make this inside the cube root of maybe negative 8. So that's negative 5, right? So if I choose negative 5 for x, so the y value, if this is negative 5, the negative 5 for x, that will be negative 8. So the cube root of negative 8 is negative 2. So that will be negative 2 times negative 2 is 4. 4 plus 2 is 6. Okay, so we have another point, negative 5, comma 6. Okay, so that is another point. So negative 5, comma 6. So which is kind of reasonable because we do have this point, negative 5, comma 6 is gonna be something right there. So as I mentioned, like maybe I should have graphed that as well, but the last graph that we have was this guy, right? Y prime prime is equal to square root of x minus 3 plus 2. So this is the line that we are going to reflect when you multiply by anything negative, so which is -2. So that means this branch will be reflected this way. So which is why we can just connect those. So I can't exactly find this point by plugging x equals 0, but I think we don't really need that. So it will be something like this. And then if I do the same thing with this, so this branch will reflect over this green line. So because of -2, so it will be something like this. Okay, so if you really want to get actual graph, exact like curve, which is actually this one, but to confirm, I would say, then you can now check this graph by a calculator, okay? That would be your answer. But how do we do this, right? So like, how do we get exact points? You know, what we just did was we will look at the numbers in our equation and see how each numbers affecting your parent function, and based on those, we were able to slowly find each effect, and then finally this green one is our final answer. So I hope that makes sense. Again, if that's too complicated, so you have to do a little bit more exploration, maybe using some tools like maybe Desmos. So that will help us to see how each numbers are affecting, because memorization doesn't really help because you're going to forget soon. So if you kind of see each change is affecting the graph, and then that will be way better to remember. Okay. So I'll see you next time.